All right, my friends, I'm going to go ahead and just handle the partial fraction decomposition off to the side. All right, starting with the form, we'll have ax plus b, just a generic linear function, over x squared plus 9. I hope it makes sense. I'm going to leave that a quadratic, since in order to factor it, I'd need to use imaginaries. And then I would have a, whoops, don't want to use b again there. Here we go, cx plus d, a generic linear over that squared, so that my least common denominator is the quantity x squared plus 9 squared. Okay. All right, now let's think about this. So we'd have ax plus b over x squared plus 9, and it would need to get multiplied by just x squared plus 9 over itself in order to get the denominator that I started out with. And then what would cx plus d over x squared plus 9 quantity squared need to be multiplied by to get the same denominator we started out with? That's right, nothing. Or 1, however you want to think about that, I guess. Anyway, so now let's see what I've got. Oh, goody. So multiply these together. So we'd have ax cubed plus 9ax plus bx squared plus 9b plus cx plus d all over x squared plus 9 quantity squared. Okay. All right, denominator battle 1. Now let's win the numerator battle. Or at least let's fight it, right? All right, so from here, I'm going to set the numerators equal to each other. And I'm going to group this mess together by powers. So ax squared plus, oops, ax cubed that is, plus bx squared plus 9a plus cx. Okay, let me check off the ones I've done. Okay, there we go. Plus the quantity 9b plus d. Oh, good, good. Okay. All right, now let's solve the mystery a little bit at a time. So since on the left side, I don't have any x squareds, or sorry, x cubes that is, sorry, a would have to equal 0. And then on the left side, I have 1x squared, so that means that b would have to equal 1. It's always nice. I know that 9a plus c must equal -1. And I also know that a is 0, so that means c would have to equal -1. And then I know that 9b plus d would have to equal 9. And I know that b is 1, which means d must be 0. Well, that's super cute. Okay, so let's put all of our values back into our form and then substitute it into the integral. So this would be the same as the integral of, let's see, 1 over x squared plus 9 minus x over x squared plus 9 quantity squared dx. Good times. Okay. The first integral looks like an arctangent, and the second integral looks like a u substitution where I let u equal x squared plus 9. So let's go for it. I'm going to split this into those two integrals that I'm talking about. And on this first integral, I personally like to get a 1 there instead of the 9, so I'm going to factor 1/9 out. Okay, and then the second integral, let's see, I'm running out of room here. Actually, maybe I should just, oh, yeah, I could go to the left, can't I? No, I can't. Boo. I'll just go down to the next line. Let's c. Actually, let me make a note here. Now, where do I want to fit this? Boo. I did not space this out very well. Just write it down here. All right, for the second integral right here, let's say I let u equal x squared plus 9, and then my du would be 2x dx. And that means that the x dx that I have there would be worth half of a du. So that means that second integral I could write as minus 1/2 times the integral of 1 over u squared du. And 1 over u squared, I'm going to be better off thinking of that as u to the negative 2. There we go. And then for this integral right here, that first one, the arctangent, I'm going to use w. I'm going to let w equal x over 3, which is 1/3 x, by the way. And then my dw would be 1/3 dx, which you could think of dx then as 3 dw's. So that means I could think of the first integral as 1/9 times the integral, times 3 times the integral of 1 over w squared plus 1 dw. I'm going to bring the second one down. Okay, so 1/9 times 3 is 1/3, and then I'd have arctangent of w, and w was x over 3, minus 1/2. And then you could use the power rule, add 1, divide by the result. So you'd end up with 1 over u, negative 1 over u. Yeah, so then it would cancel with this negative. And then u is x squared plus 9. There we go. And then don't forget plus c. And I think I'm just going to leave it like that. There we go. All right, hopefully this is making sense, and hopefully I'm not totally screwing this up. All right, my friends, for the challenge, the part that makes it most challenging actually is the algebra 2 part of factoring that denominator there. It just won't factor with grouping or any fun stuff. So you're going to fall back on the rational zeros theorem, aka the P over Q thing. So I put the coefficients for the polynomial there. I'm going to use what's called stacked synthetic, where I don't show the work row for synthetic. You can do whatever works for you. So really quick, I'm just going to see if positive 1 is a 0 of this. So I'm going to drop the leading 1, multiply, I get 1, add, and I get 0, multiply 0, add 1, multiply 1, add 4, and I just found out that positive 1 is not a factor. So let's move on to negative 1. So dropping the 1, multiply, you get negative 1, add, you get negative 2, multiply, you get 2, add, you get 3, and multiply, you get negative 3, add, you get 0, which means we just factored that polynomial. So the polynomial previously known as x cubed minus x squared plus x plus 3, we now just factored it as x plus 1 times x squared minus 2x plus 3, like that. All right, now think for a second about this quadratic and, think for what, 4 seconds? And if you can't factor it, it means it's probably not factorable using rational numbers anyway. And so what that means is that I'm going to leave this as a quadratic. Okay. All right, so now moving on to partial fraction decomposition. I'm starting out with x squared minus 4x plus 7. And I'm just going to set up the form. So I'd have a over x plus 1 plus bx plus c over x squared minus 2x plus 3. Okay. Getting common denominator, a would need to get multiplied by x squared minus 2x plus 3. And bx plus c, oops, that's not how you want to write that. bx plus c, that quantity, would need to be multiplied by x plus 1. All right, and I didn't write the denominators because at this stage, this is probably where you start skipping steps as long as you know you're okay with that. Okay, so then I'm going to distribute the right side. I'd have ax squared minus 2ax plus 3a plus bx squared plus bx plus cx plus c. There we go. Okay. Okay, so let's see. On the left, I have 1x squared. On the right, I have a plus, do I seriously have 4x squared, or did I just write that funny? I totally wrote that funny. That should be bx squared. That makes more sense. Okay, all right, so that means 1 would have to equal a plus b. Okay, on the left, I have negative 4x's. On the right, I have negative 2a of them plus b plus c of them. On the left, my constant term is 7, and on the right, my constant terms are 3a and c added together. Okay, I personally like substitution for a system of equations that looks like this. So let's see. I think I'll try to get the second equation in terms of a. So on the first equation, I'm going to isolate b. I'm going to get b in terms of a. And on the third equation, I'm going to isolate c. And then I'm going to use those into row 2 to get everything in terms of a. So row 2 would then say that, and then simplifying it. And then just solving the equation. I think we get a equals 2. I think so. And then since a is 2, you get back substituted right there and get b. And then you could take both of those and, or either one, I guess. I think I'll use there. We'll put 2 in for a there. It looks like c is positive 1. Okay, let's see. Did this work? Did I mess this up yet? All right, we're about to find out. Okay, so whoops. All right, we're going to take our a, b, and c values that we just found, and we're going to sub them back into our form, and then think of our integral in that sense. All right, so this would be the same as the integral of 2 over x plus 1 plus negative x plus 1 over x squared minus 2x plus 3 dx. There we go. Okay, now we've got 2 integrals. The first one, you could factor the 2 out. And the second one, I actually super love just the way it is. And before you get sad at all about the second integral, remember that with rational functions, the first thing we learned and the first thing you should always consider and rule out or in is letting u equal the denominator. Oops. Notice that my du that I just got is 2 times x minus 1 dx. So that means x minus 1 dx is equal to half a du. So the first integral, back to the first integral up here, that one, if you did a u substitution on it, that your dw, I guess, would equal your dx. And so you get 2 times the natural log of just that denominator. No funny business on that one. And then the second integral, we just have 1/2, and then times the integral of 1 over u du. There you go. So we ended up with 2 times the natural log of the absolute value of x plus 1 plus 1/2 times the natural log of the absolute value of x squared minus 2x plus 3 plus c. All right, my friends, and if you can make sense of anything that I said to you in this lesson, especially the paper crane thing, then give yourself a huge pat on the back. And also get ready for Valentine's Day, okay? All right, take care, everybody.